Question 4 asks, why is dimerization often a requirement for the function of receptor tyrosine kinases? All right, so a receptor tyrosine kinase is basic. I'm going to just draw them as these two little kind of lines here. Right, these are our RTKs. All right, so normally a lot of receptor tyrosine kinases basically exist as monomers that when a hormone is bound here on the outside of the cell will cause these two subunits to basically come together so that now the two subunits are basically binding to the hormone. Now, the reason why this dimerization is actually important is that each of these, the way the receptor tyrosine kinases work is the intracell, the portion of the protein inside the cell, so bottom part here. These intracellular domains here have two functions, right? One is that they are kinases. They're tyrosine kinases, so they will phosphorylate tyrosines. The other is that they actually contain the tyrosines that can be phosphorylated. Now the problem is that the sites that can be phosphorylated are basically not able to reach the kinase site. So they're basically kind of separated here. But when we actually bring two of these receptors together, now the kinase site is brought close to the tyrosines on the other subunit, and the other subunit's kinase is brought close to the tyrosines on the first subunit. So they're actually able to cross-phosphorylate, whereas when they are apart, if I take this and move it apart here, the individual subunits, basically their kinases can't phosphorylate their own tyrosines. They can only phosphorylate the tyrosines on the other subunit when these two subunits are brought into close proximity by the hormone binding. So that is the answer for this question.